Gentlemen, thank you so much for braving potential terrible weather and coming and joining us here at UNSW Founders at the Michael Crouch Innovation Centre, the heart and home of innovation here at UNSW. My name is Nina Yule. I'm a Senior Manager here at UNSW Founders, and it is my privilege to work every day within this space, helping people take great ideas and turn them into meaningful impact and hopefully brilliant startups. You have found yourself at UNSW Founders First Thursdays. Can I just get a little round of applause if you've come to one of these events before? Okay. And a little round of applause if this is your first time attending a First Thursdays. Ah, wonderful. Thank you so very much, both for being brave enough for a little bit of audience interaction, but also for taking the punt and trying something new. First Thursdays is the monthly event here that we house at the Michael Crouch Innovation Centre, and the intent is to bring people like you, our community, startups, investors, mentors, community members, students, researchers, anyone who is invested in and passionate about innovation into the one room together to create a mixing pot of great ideas, inspiration, and hopefully great connections and networking. All of that is sandwiched either side of an inspiring conversation, which I will shortly introduce you to our brilliant guest speaker. So before we start, I'd also like to properly take a moment to pause and acknowledge the traditional owners of the land in which we gather, the Bedegal people of the Eora Nation, and acknowledge the fact that wonderful conversation, skill sharing, expertise and networking has been happening on this land for thousands of years. So this evening, for the month of May, we are very lucky to be exploring the world of biotechnology and medical commercialisation with the extraordinary Professor Shane Gray. Shane is the head of the School of Biotechnology and Biomolecular Sciences at UNSW and, work with me here, I tried to practice this, Head of Transplantation Immunology Laboratory at the Garvan Institute of Medical Research, a proper mouthful. Shane has extensive experience in both medical research, commercialisation, and is extremely revered internationally and here in Australia with his insights, humble nature and experience in walking these steps and exploring potential outcomes for greater good for our world. This evening he'll be interviewed by our very own Maddie McCoy, who is the our Bio10X Accelerator Program Manager. Maddie is passionate about research commercialisation, the bioeconomy and increasing Australia's manufacturing capabilities. This is going to be a fascinating conversation. I won't let you hold you up from that conversation any further. Please welcome me warmly with a final round of applause to our guest this evening.
Thank you, Nina, for that beautiful introduction, and thank you all for being here. And Shane, thank you so much for coming. Before I jump into the questions, I want to say a couple of things about Shane that you wouldn't find on his LinkedIn bio or his UNSW staff profile. So Shane really loves hiking, and he really loves the journey that it takes you on. And when you get to know Shane, you can see he brings that journey taking into his professional life. He's incredibly humble about what he does. The list of achievements go on, and when you meet him, he's just such a humble guy, which I think is amazing. And he gets stuff done, which, is a real testament to the fact, everything he's done in his life and the journey that you're going on now. And lastly, he's one of the most chilled researchers I've ever met. Don't let the suit fool you. He's usually in a shirt that's got like peaches or something on it. So yeah, that's a little bit about Shane that I've got to know in probably the last 8 months. So on to my first question. Why did you become a researcher in immunology? What was the turning point for you in your career that decided you wanted to become a researcher in this space and commercialise your research?
That's a lot. Hey, thanks for the introductions. They're pretty... Am I on mute still? Or did I just turn myself off? Okay. Can you hear me at the wherever? I got a thumbs up there. That's cool. Yeah, thanks for all that. Actually, to out myself, I'm going to a posh function later. That's why I don't. That's why I don't have the peaches on. But yeah, so. What was the question?
That's fair. I think I had like 3 questions in there. Why did you become a researcher in immunology?
Researcher. I literally was always curious about things. Just, you know, when I was a kid, I always wanted to know how things work. Actually, my mum has this very cute but slightly embarrassing story she tells, which was that I was lying under a tree, probably 9. She was maybe watering the garden, and I said, "Mum, how come the spiders can walk on the webs but the flies get stuck?" And I think I've just been like that my whole life, just how do things work. And I think that I felt that curiosity about the world, but also wanting to work out how you can use knowledge to make change, are things that made me really want to choose the life of research.
Yeah, I love that. You know, working in science, you've got to be curious, right? But I'm really interested. So when I started, you know, my science undergrad, one of my lecturers said, immunology is the hardest field, it's so difficult. So I thought to myself, oh, I'm not going to do that. So was there anyone in your journey that was really influential into why you decided to take this path?
Oh yeah, immunology is funny. So all my majors were genetics, physiology, that type of thing. And I think in 3rd year, we had there was a lecturer giving us a talk about cancers, and they were I guess their specialty must have been leukemias, which are an immune cell cancer. So they figured for us to understand that, we needed to understand some immunology. And one of the things they talked about, I don't know if you've ever heard of this thing called complement, which is essentially these disassembled Meccano set that literally floats around in your body.
What's a Meccano set?
See, that's the divide. How about self-assembly molecular machines? Do we like that better here? Lego? We can go Lego? All right, so Meccano's up from Lego. There you go. And but when there's a primal part, when it detects a bacteria in your bloodstream, it latches on, and then another part latches onto that. They form a little machine that catalyzes a reaction that brings in another part and essentially self-assembles and builds a drilling rig which punches a hole in the bacteria. That's complement. Simple. Right? And I just thought, what? And then a little bit more about immunology and killer T cells, and I was just like, what is this? I remember walking out of that lecture going, I don't know, the only other feeling I've had is kind of like love at first sight. I was just like, this is the most incredible field. So I changed unis, went to another place, found people who teach me immunology, and haven't really looked back from that.
That's amazing. And yeah, just a testament to how complex the immune system is and so important. So right now, and I'll try and explain it in my sort of dumbed down version of what I understand that you're working on at the moment. So Shane's working on a gene therapy technology that, okay, step back. People who have type 1 diabetes, one of the, I guess, pressing issues for people with type 1 diabetes is secondary illnesses, right? Mm-hmm. Where they take the insulin and the repeated taking of that insulin is actually destroying their kidneys. Is that correct? Well, sort of.
Can I have a go?
Yeah. I'll let you explain.
So look, I guess the really big picture is autoimmune diseases, autoinflammatory diseases, like in the US, massive unmet need, 90 billion a year apparently in the US. In Australia, just inflammatory bowel disease alone is 90 million. And in healthcare costs, a diabetes healthcare report that just got tabled to the government said 2.3 billion for type 1 diabetes when you put all the associated costs of lost work, but hospital care and so forth. So you're absolutely right, people take insulin, but what we say is it's a treatment. And the issue is that insulin is trying to get your blood sugar back into the normal space that it should be, the normal like highs and lows. But for people with type 1 diabetes, their bodies naturally are unable to do that without insulin because they can't make their own insulin. But even with this treatment, it's still not good enough to stop the ups and downs of the sugars causing damage to the body. So for instance, 25% of people with type 1 diabetes will lose the function of the kidneys, and you can't live without your kidneys. So in Australia, there's about 150,000 people with type 1 diabetes. So we are looking at now, you know, what's that? So that's about 30,000 people who are going to need a life-saving kidney transplant or go on dialysis. Right? Dialysis, your lifespan is about 10 years, and that costs about $100,000 a year. A transplant's about $200,000. I mean, plus the economic burden of looking after other complications and issues. So that's what kills you a lot with these sorts of diseases. So, and there's a fraction of patients where even insulin doesn't even preserve a nominal function, and they suffer from a thing called a very severe brittle form of diabetes, which leads to a syndrome called dead in bed syndrome, where children can die from sleep because they go unconscious from not having sugar control at the right levels. So even though on one hand you think, oh yeah, it's kind of managed, there's real big issues with this behind the scenes that, just basically represents a massive unmet need, which is the same for many other autoimmune and inflammatory conditions.
That's awful. Yeah,
Yeah.
such an awful illness. If autoimmune diseases are so complex and so complicated to treat. So I want to flesh out how in your research journey, I think scientists, they're actually great entrepreneurs because a lot of science ends in failure. And, in startup land, we talk, fail, go out, risks, etc. But research, we're so used to it. We're 90% failures in experiments. So in your journey of your research, were there any failings that helped lead to a discovery?
Yeah. I brought the list. Where do we start? I think, look, there's so many things along the path. I think the passion was to address that unmet need, and then over time develop, we're calling it a gene therapy, which it is, an approach that could actually solve and deal with a part of the inflammatory cascade, let's call it, that had not been touched by any drugs. So therefore we saw a new opportunity. And essentially, with a gene therapy, they have to be delivered by a biological mechanism, which we call a vector. And essentially we did years of research and development in animal models with a lot of really good peer-reviewed funding to build essentially a proof-of-concept gene therapy drug, let's call it that, right? And then, all the pieces are coming together and it's looking in the animal models like it's working like a charm. We're getting great effects in terms of ameliorating inflammatory disease in really relevant animal models, like spectacular data. So then we start going to clinical colleagues and say, hey, how do we get this into the clinic? How do we translate this? Start talking to regulators and start talking to potential financial backers. Fail, fail, fail. So the failure with the clinicians was that, and the regulators actually, they joined up forces. They basically both said, we love the therapeutic candidate, the disease indication, no issues. We can see how it can target that, but the vehicle you've chosen, that will never pass regulation because the type of vector, like very fundamental to the drug, let's say, that formulation would never pass regulation because it was a virus that's quite common to use viruses to engineer cells, would have a very strong inflammatory effect on the cell itself. So they said, you're not going to pass safety. And then the clinicians would say, what do the regulators say? And the regulators say, what do the clinicians say? And they're all kind of saying the same thing. And then, of course, the funders go, what do the clinicians say? So then that was really terrible because essentially I got to the end of a 10, 12-year journey going, shit, I thought we were really on it, right? And then I had this sort of chance meeting with a guy who just got invited to come to the Garvan to talk for some other purposes, and they said, oh, such and such is here. It turned out this was a senior person for the regulator of UK gene therapy. And I thought, what a great opportunity to talk to someone outside my space, right? So I was a bit nervous about this because I just had total failure around the whole thing. And I went up and said, this is what we're trying to do. What do you think about this? And he said, that's never going to work like that. You'll never get that past the regulators. I said, thank you. And he said, well, have you considered this? And there was another viral technology that was emerging that, researcher, you're in your own rabbit hole, you're going for your thing, staying focused. And he talked to me about another basically vector vehicle that was being developed in other gene therapy approaches and had promising safety data. And there was a couple of lead places in the US and elsewhere that were using this and in Europe. I was like, whoa, but then what do you do? Because now I've got to go back to the funders and say, whoops. So we were trying to build a ute, somehow looks like a two-door sports car. Can we have a lot of money again to rebuild it, but as a ute, right? And actually in the US I found people who would fund that because they saw the clinical need, they saw that the clinicians, and so then I went on a roadshow to the same clinical network, some in the US for instance, and said, if I flipped it into that, would you try it? And they said, yes. I was like, okay, there we go. So then managed to raise a whole pile of funding just to basically do reformulation, which took another 5 years. But now we're at the point of, actually, hopefully this time next year we would have put it in a person. So that's the track we're on right now. So, but yeah, that's that failure, I guess the failure, what is it? So I think the question then out of that was, what failed, right? So I felt at first obviously devastated. It's like, okay, it's not going to work. But then I guess what I learned from all that experience is keep asking questions, be open to new information, don't be scared of networks, don't be scared of going to people who might have information. And then, obviously if there was the first thing, I was like, oh, they're all wrong. I'm just going to push on. And it's like, oh no. It's like the 5 stages of death. I had to get to the part where it's like acceptance, right? But then once I could accept, I could understand and receive new information. And then it's determination again, which is what got you there, right? You have to be pretty, say, okay, well, do I believe in this? And then off you go again.
Yeah, and not giving up. Sounds like you had failure after failure after failure after failure.
There's a few.
And what was that time? You said there was 5 years in Australia. How long was that?
So the timeline from, depends, I guess definitely 14 years for sure.
Long journey.
Yeah.
How long was your hike in the Himalayas?
3 weeks.
That's a long hike. Yeah, so he loves a journey. So, look, you sort of answered it, but, clinical trials are expensive.
Yes.
How have you funded your research and your clinical trials?
Yeah, this is an interesting question because it has lots of, I didn't really appreciate differences between non-dilutive and dilutive funding. And I didn't appreciate the costs. And I think probably for me, because even an earlier question is, how do I even get to that point in terms of getting that sort of funding? And I think what happened for me a long time ago, I was a postdoc in Boston and Harvard, and I was doing, my mentor at the time would take me on ward rounds with her, and there were patients with diabetes who were there for the kidney disease, as we talked about before. And I remember just walking out going, that's bollocks. I mean, we must be able to do something for that. And that's what changed me from wanting to do basic to something that was translational. But I also believe that new discovery was the core to answers, right? Because obviously then, as kind of still now, there's no real treatments for those things. But then as you start moving forward, you know that research funding, which is amazing for NHMRC and these sorts of mechanisms, is for basic research and translational from what NHMRC calls translational. But real translational, where you're starting to recruit patients and there's a whole lot of due diligence around that and, regulatory requirements and process development, which costs literally millions. That is no longer research funding. And I guess I began to realise, you need to commercialise, not just, to have a boat on the harbour, but to actually get your thing into a patient because you need that support, you need that other expertise, right? So I'm recognising that at some point, I'm not involved anymore. I'm the guy who gets it to here, but to maybe take it to that next step needs a whole lot of expertise that I don't have. And I think part of that is people who can bring in, supportive money, but it's got to be used very strategically, right? And I think that's also part of the equation, but that sort of answer.
Yeah, and I think, so with, strategy, funding, who have been key people, you don't have to say the name, but what have been their skill sets in helping you build product development roadmaps in this space and, lining that with regulatory funding, etc.?
Yeah, that's required the building of a massive team. So, for instance, let's say there's one place which is the discovery preclinical development site. There's another place which will be the actual clinical performance site. So there's a whole team with that, and there's already 2 parts to that with a clinical lead and a kind of an application lead. Then there's process production and development, which is all happening right now as well, and there's a lead for that.
Is that happening here in Australia?
Yeah. So as much as we can do in Australia, we're doing, which I must admit has also been a massive failure. So you say, okay, I want to do a gene therapy, and everyone says, oh yeah, so which drug from the US are you importing? No, I'm making it. Oh, we've never done that before, says the TGA. says any local manufacturer, because there is no way to manufacture that. So someone asked me, what's it like? I said, this is what we're actually doing. We want to get to Mars. We know where Mars is. That's cool. We've kind of got a thing what we've made up. We're building the rocket. That's cool. And at the same time, we're training the pilots. And at the same time, we're building actually the launch pad. And we're also building the place we're going to live in Mars. None of it's really been tested together. We don't know if it's going to work. Sometimes people who fund it go, but shouldn't you be doing it like that? And I was like, sure, you know. So there's a lot of moving parts. But I think the important thing is it's definitely a team. You know, don't fool yourself thinking you can do this by yourself. Get the smartest, best people you can find. Empower them to do their part, you know, and have that collegial, you know, you're not going to be, you know, you might have started with the idea, but you're not 99% at the end, right? It takes a lot of energy and people to get things into a...
Takes a village, right?
Yeah.
Absolutely. So we've got a question on the Slido, which fits in really well with what we're talking about. With the levels, yeah, go for it. With the level of investment that it sounds like was raised in the US, were there pressures to move operations or research to the US? How did you navigate that?
This is a live conversation. So I think that definitely that the VC investment and input is going to be larger in the US. But there's definitely advantages to having a base in Australia. And I think the research is in Australia that's led to where we are. I think the first in-human clinical study will happen in Australia. We want to expand that to a network we've built into, let's say, North America and Europe. I think that having the optimal structure would be, you know, there can be tax benefits and all sorts of R&D credits to have it here in Australia, but with portals elsewhere. And I think that looks to be how we'll structure this, at least in the first stage. Yeah.
Okay, another question from the Slido. How do you keep up with your journey despite the failures you've experienced? What is your best advice for an ECR, so early career researcher, passionate in following your steps?
Be stubborn. Got to be pretty thick-skinned. I think be realistic too. Like, you know, a lot of things fail, and sometimes they fail because they're just not possible, technically impossible, not really great ideas. I do have this sort of thing like, you know, we talk about some cool stuff and say, let's come back next week and see if we still think it's cool. You know, I think, you know, things, so don't be scared to try things and let them not work, you know, because I think, you know, there's that, you know, quick to fail. I think it's, you know, but all this sort of attitude of trying to be resilient, be realistic, but also believe in yourself and back yourself for things. Yeah.
Yep. Is your therapy only targeting the prevention of kidney damage, or is that just part of a bigger picture?
Definitely a bigger picture. So I think what we have is a first-in-class type of way to target inflammation, a way that's not been done before with any of current drugs that are available. I think that's part of our unique niche, is that, and that was sort of part of the reason that sort of started this is, I guess, think of it like this, these people with lots of different autoimmune diseases, lots of inflammatory conditions, transplant rejection, essentially all the drug cupboard is the same. It's just mix and match for different patients. And we know that everyone responds differently, not everyone has the same equal outcome. And so the question is, why is that? If the immune system is the problem, why does not smashing the immune system and shutting it down work? So, and as simple as that, just looking at this thing one day going, well, there's the immune system attacking the tissue, and the immune system causes the problem, and we target the immune system, but we don't always get the right answer. And I literally just went, well, what if this is also playing a role? What if the tissue is also playing a role? So the fundamental research part was showing that in these kind of very complex physiological conditions, the tissue plays a big role in driving the immune response. So that then led us to think, oh, how can you get to the tissue in a way that doesn't, and the benefit of that then is you don't have to immunosuppress someone. And I think that's our party trick, right? Is that we've found a way to do something that no one has thought of that plays a major role in disease that I think will give us an edge in changing that whole paradigm. And I think that's where you know, you can start thinking about why type 1 diabetes. Well, we did that because we figured that that was the first way to get into human. But then the plan is with that data, we then are at the moment scoping out what we think is the best, biggest indication we can go for, like an orphan disease that's got an inflammatory drive. I mean, like one of my heroes is the woman who runs Spark Therapeutics, which developed a gene therapy for eye. I mean, they just got bought by Roche for like $3 billion. And, you know, that's $800K a shot. I mean, like, and it's having a major impact in eye disease. And I'm sort of thinking, you know, this is where this could go, right? Yeah. Right. So basically it's about working out, and I think that's another question, you know, someone said, how do you make it happen? You know, you might be trying to get to the moon, but maybe that's okay just to get to Norfolk Island first. You know what I mean? Yeah, that's okay, right? Because you've really shown you can do it. And that's actually a big deal, I'm learning, right? I never realized that the word process development was so powerful. But believe me, when I discovered this about 2-3 years ago, you know, and you just say that, I'm doing this, and people go, oh, wow, that's pretty cool. You know, it's all about that capability and showing. So definitely the first is find an unmet need, which we think will have big impact, which we've already got a revenue prediction based on, which will be fairly substantial, but then leverage that to really go after the next step. So I kind of think it's like a Russian doll. We're going to go for other stuff. But what's that weird thing? When investors always say, and people, at first I was like, oh, we're going to do all this stuff. They say, oh, you're so unfocused, never going to happen. So I said, okay, we're going to do T1D, and we're doing this, and yeah, but that's only that? I mean, what else could you do with this? Okay, so any investors out there, you've had both answers. We can do it all.
With a great team.
With a great team. It's all about the team.
Yeah, there's a lot of amazing questions coming through, but we probably have time for one last question. And I'm sorry, it's going to be my question.
It's not at all a Ponzi scheme. And I didn't write it, okay?
Yeah, really, really easy one. What's next on the agenda for Shane Gray?
What's next? Oh. Well, I guess definitely, you know, the focus is really on TGA and process development getting finished. I'm hoping we're going to have little vials of my drug in the freezer by Christmas. TGA hopefully will be approved. HREC's nearly approved. The trial arm, the control arm of the trial is actually finished. So we've already, and we'll be looking to recruit patients for this next phase. So that's all pretty exciting. I guess one of the fundamental discoveries that we've made is that we've essentially found how the body controls its own immune system. And we've found a switch the body uses. And we're using gene therapy to manipulate that. So we're using it at the moment. Our first indication is to go to turning it off in inflammation. But we've also worked out we can reverse that and actually turn the immune system on. And I guess we were thinking, you know, where's a good place to turn the immune system on? And I'm thinking cancer, oncology, CAR T cells, and tumour infiltrating lymphocytes, which is a blockbuster therapy for a lot of cancers. And we've had some really good feedback from investors around that space. We've had a lot of funding from the federal government for that. And so we're doing proof of concept work at the moment. And we're actually, sorry to plug you, but we're looking at the Bio10X program to put in our little baby oncology program into. So I feel like that's, and we're talking to some local biotech about that as well. So that's probably the next, I don't know whether we should have a next. There's a lot happening.
It's a lot, yeah. And, you know, on top of that, head of school. So,
Yay, Babs!
so thank you so much. I'll hand over to Nina.
Ladies and gentlemen, please join me in thanking Shane and Maddie. That was such a fun conversation and really insightful. The couple of notes I made that I really liked was, and I think I might try and apply the Russian doll market approach of single focus and then expanding your product range out. I also particularly like the 5 stages of death of startup growth and progress, from keep asking questions, don't be afraid to network and build those connections, be curious, don't give up, and believe in your work and impact. That was, really brilliant. So thank you so much for sharing your story, your journey, and the conversation. There are more questions on that screen. Luckily, there is more time to ask them. So this is the second half of First Thursdays for those who have not come along before, and arguably some of the most important time. This is the time to network. So my ask for you is find a founder, ask them what they're building, what they're working on, what their asks and challenges are, and see if you can help them. If you can't talk to a founder or you're a founder yourself, find 2 people that you've not met before and have a conversation. Share your visions, your challenges, your hurdles, and make those connections. Because as Shane said, don't be afraid to network. You cannot do it alone, and that is exactly why we create events like this at First Thursdays, to help people connect, grow, and hopefully make incredible life-changing innovation for the rest of the world. Thank you so much for joining us this evening. We've got some lovely hot food and drinks and pizza up the back. Hopefully we see you again next month, and have a lovely rest of your evening. Thank you.
I prefer